Having said all of that, we now should get to the new game. But before we do, I'm going to remind you that you've already been in it. You all got packages. And we're now going to see a little bit more about what overdrive is all about.
Welcome to another exciting first competition year. I'm Vince Wolzinski, a first supporter from the U.S. Coast Guard Academy.
And I'm Aiden Brown, a systems engineer from General Dynamics. We want to walk you through some details of the first infrared board that was sent to teams in late December as part of the game hint.
The board is an IR receiver that recognizes signals from standard remote controls. Once trained for your remote controller, the board produces a 5-volt, 100 millisecond pulse for each of the 4 buttons on your remote control. The positive side of the power source can be between 7 and 15 volts and is applied to either pins 1 or 2, and the negative side is connected to either pin 3 or 4.
Pins 5 through 8 are the outputs associated with the 4 buttons you train the IR board for. The pulsed 5-volt signal is delivered to each pin based on the button pushed on the IR transmitter. Pins 3 or 4 can be used as the ground for these pins. Before the board can be used, it has to be trained with the remote you wish to use. A series of steps are used to train the board. First, with no power supplied to the board, hold down the Learn push button while turning the power on to the board. The error LED will light to signal the power is received. Wait for at least 2 seconds and then release the push button.
The error LED will blink for a second, and then the LED for the first channel, CMD0, will light up. This indicates that channel is ready to learn what button on the remote will activate it. To teach the board, hold the remote 4 to 6 inches away and shade the receiver from any bright light. Press the remote button down and hold it until the CMD0 LED turns off. When the LED turns off, release the remote button. The CMD0 LED will light up again. To complete the training, you'll need to press the same remote button down a second time, releasing it when the LED turns off.
When the second LED lights up, you then hold down the second button on your remote transmitter and repeat the process twice to teach the receiver that this is the second button. The same process is repeated on the third and fourth buttons. Once all 4 buttons are programmed, the board will automatically switch out of programming mode, and then it's ready to use.
We can look at the signal generated on pin 8, the output signal associated with the first trained button, with the help of an oscilloscope that measures the voltage between this pin and the ground pin at 3 or 4. For this remote, if you hold down a button, the signal is transmitted continually, and we see a series of pulses on the oscilloscope. Each pulse has a magnitude of 5 volts and lasts for 100 milliseconds, which is a tenth of a second. Each flash of the LED corresponds with the transmission of a 5-volt pulse on the assigned pin.
Now, there are a few errors that can occur during programming. If the LED flashes continually, you need to power down the system and start again. It may be that the receiver is getting too much ambient light, a problem that can be solved with shading, or that the remote you are using operates on a protocol not recognized by the receiver. While the O-scope example used a remote that sent a repeated signal, other remotes send a signal pulse if the remote button is held down. Now, if you've trained your remote successfully, but it doesn't respond when you're more than a few feet away, it's probably transmitting on a different frequency. You'll need to find yourself another remote.
There are a few tricks you can use to make sure your transmitter is seen by your board. Though you trained your receiver to see your transmitter, the receiver can be confused if it simultaneously sees other signals from stray transmitters. If this happens, the output pulses will be less reliable and may even be blocked. Tubes can be used to restrict the angles of the transmitted and received signals. On both the transmitter and receiver, the tube restricts the outgoing and incoming signals to a more direct line of sight and greatly reduces interference between different remotes.
And now for the fun part. Since the IR board generates 5 volts, and coincidentally, the robot controller receives 5 volts, it might be interesting if we hook the 2 of them together. To do so, we can get 12-volt power from the robot's main fuse panel. and connect the 4 output pins on the IR board to digital inputs on the RC. Any digital input could be used for the IR receiver.
Pins 5 through 8 on the IR board could be directly connected to the RC signal pin as a digital input. Program code could be written to allow the robot controller to recognize a change of state each time one of the 4 buttons on the remote is pushed. Knowing how tightly teams are connected, I'm sure the FIRST community will collectively determine how to make this system perform at its absolute best.
But Vince, what will teams do with a remote control, a FIRST IR board, and a robot?
Well, the sky's really the limit. Maybe we can find someone from NASA who knows how to talk to robots.